Today we are going to discuss diagonalization of a matrix. So first, what is diagonal matrix? So in any square matrix, except the diagonal element remaining all are 0 is called the diagonal matrix. Okay, now so we need to find the diagonalization of a matrix. Means if any matrix is given, so how to find the diagonalization of a matrix? So there is a procedure. So first, if any square matrix A is given, so write down the characteristic equation of that matrix. Characteristic equation of matrix. So that is modulus of A minus lambda I equal to 0. For that we take lambda cube minus C1 lambda square plus C2 lambda minus C3 equal to 0. Here what is C1? C1 is the trace of A, and C2 sum of minors of diagonal elements, sum of minors of diagonal elements, and C3 equal to det A or mod A. C3 is. So by substituting these values here, we get the characteristic equation of that matrix. So by solving this characteristic equation, we get the lambda values. So if the matrix is a 3 by 3 matrix, we get 3 lambda values. Those are the eigen values of that matrix. So after that, find the eigenvectors. For each eigenvalue, we have one eigenvector. So here there are 3 eigenvalues, means we get 3 eigenvectors. Those are denoted by x1, x2, x3. So after finding the eigenvectors, we write the model matrix P. That is model matrix P equal to matrix in the form of eigenvectors x1, x2, x3. So after finding the eigen model matrix, find det P value. If det P is not equal to 0, then P inverse exists. If P inverse exists, the diagonalization matrix D equal to P inverse AP. The diagonalization matrix D equal to P inverse AP. This is the procedure to find the diagonalization of a matrix. Okay, we do an example, one problem. Problem చెప్పండి. First problem చెప్పండి. Matrix
1 1 1
1 1 1
0 2 1
0 2 1
minus 4
minus 4
4
4
3.
3. So this is the matrix, square matrix, 3 by 3 square matrix. So now we need to find the diagonalization of this matrix. So first write down the characteristic matrix. A minus lambda I, that equals to 1 minus lambda 1 1 0 2 minus lambda 1 minus 4 4 3 minus lambda. Now the characteristic equation modulus of A minus lambda I equal to 0. For that we take lambda cube minus C1 lambda square plus C2 lambda minus C3 equal to 0. Then what is C1 here? C1 equal to trace of A. Trace is nothing but the sum of the diagonal elements. So 1 plus 2 plus 3, that equal to 6. And then find C2 equal to sum of the minors of leading diagonal elements. So here the diagonal elements are 1, 2, 3. So the minor of this first diagonal element 1 equal to the determinant of 2, 1, 4, 3, 2, 1, 4, 3, and the minor of this element is 1, 1, minus 4, 3. The get of 1, 1, minus 4, 3, and the minor of this element 3 equal to the determinant of 1, 1, 0, 2. So now find the data of these values. 6 minus 4 plus 3 plus 4 plus 2 minus 0, that equal to 2 plus 7 plus 2, 11. Now C3 equal to det A. So what is det A? So 1 into 6 minus 4, 2, minus 1 into, leave this column and row, the data of these 4 elements, 0 minus of minus plus 4, plus 1 into, leave this column and row, 0 plus 8. So 2 minus 4 plus 8, 10 minus 4, 6. So by substituting these values C1, C2, C3 in this equation, we get the characteristic equation lambda cube minus 6 lambda square plus 11 lambda minus 6 equal to 0. This is the characteristic equation of the given square matrix. So now find the lambda values. That lambda values are called the eigen values of that matrix. Lambda values ఒకసారి చేయండి అమ్మ క్యాల్సిలో.
1, 2, 3.
So 1, 2, 3 are the lambda values. So these are the eigen values of this matrix. So we find eigenvector for each eigenvalue. For each eigenvalue we find the eigenvector. So eigenvector for lambda equal to 1, that is a minus lambda I into x equal to 0. Now substitute this lambda equal to 1 in the characteristic matrix. So that is 1 minus 1, 0, 1, 1, and 0, 2 minus 1 is 1, 1, minus 4, 4, 3 minus 1 is 2, and x is x1, x2, x3, that equal to 0. So now multiply 0 into x1 is 0 plus 1 into x2. Write down the three equations. X2 plus x3 equal to 0. This is equation 1. Next x2 plus x3 equal to 0. This is equation 2. Minus 4x1 plus 4x2 plus 2x3 equal to 0. This is equation 3. So solving any two equations, we get the values of x1, x2, x3. So solving 2 and 3. Solving 2 and 3. So use this method x1, x2, x3 to find the values of x1, x2, x3. So first write down the coefficients of x2. So in second equation coefficient of x2 is 1, and in the third equation coefficient of x2 is 4, and x3 coefficients are 1, 2, and the x1 coefficients are 0, minus 4. Again write down the x2 coefficients. So doing the cross multiplication, x1 by 2 minus 4 and x2 by minus 4 minus 0, x3 by 0 plus 4. So x1 by minus 2, x2 by minus 4, x3 by 4. So divide with minus 2, minus 2 one time, 2 times, minus 2 times. So the eigenvector for lambda equal to 1, that is denoted by x1, the first eigenvector, we write x1 equal to 1, 2, minus 2. 1, 2, minus 2. This is first eigenvector. Now again find the second eigenvector. So eigenvector for lambda equal to 2. Lambda equal to 2. So substitute this lambda value in the characteristic matrix. So characteristic matrix. Now write down the matrix. 1 minus 2 is minus 1. 1, 1, 0. 2 minus 2, 0. 1 and minus 4. 4. 3 minus 2, 1 into x1, x2, x3 equal to 0. Now write down the equations. So minus x1 plus x2 plus x3 equal to 0. This is equation 1. x3 equal to 0. Equation 2. Minus 4x1 plus 4x2 plus x3 equal to 0. This is equation 3. So solving 1 and 3, we get the values of x1, x2, x3. Solving 1 and 3 using this method, x1 cross multiplication method, x2 and x3. So write down the x2 coefficients 1, 4. Again x3 coefficients 1, 1. Again x1 coefficients minus 1, minus 4. And again x2 coefficients 1, 4. Now find x1 value, cross multiplication of this one minus this one. So 1 minus 4, like here, minus 4 plus 1 and x3 by minus 4 plus 4. So x1 by minus 3, x2 by minus 3 and x3 by 0. So divide with minus 3. Then eigenvector x2 equal to 1, 1, 0. So here if we divide with minus 3, we get 1, 1, 0. So that is the second eigenvector. Now we need to find the third eigenvector. So eigenvector when lambda equal to 3. Eigenvector when lambda equal to 3. When lambda equal to 3, it is a minus lambda I into x equal to 0. Substitute this lambda value in the characteristic matrix. So 1 minus 3, minus 2, 1, 1, 0. 2 minus 3 is minus 1, 1, minus 4, 4, 3 minus 3, 0 into x1, x2, x3 equal to 0. Write down the three equations. Minus 2x1 plus x2 plus x3 equal to 0. This is equation 1. Minus x2 plus x3 equal to 0. This is equation 2. Minus 4x1 plus 4x2 equal to 0. This is equation 3. Now solving 1 and 2. Solving 1 and 2. So by cross multiplication method, x1, x2, x3, write down the coefficient of x2, 1, minus 1, 1, 1, minus 2, 0, 1, minus 1. So x1 by 1 minus of minus plus 1, x2 by 0 minus of minus plus 2 into 1, 2, x3 by 2 minus 0. So x1 by 2, x2 by 2, x3 by 2. So divide with 2. So eigenvector x3 equal to 1, 1, 1. So after finding the three eigenvectors, write down the model matrix. So model matrix P equal to x1, x2, x3. Write down the model matrix. Model matrix P equal to x1, x2, x3. So what is P? P equal to x1 values 1, 2, minus 2. And what is x2? 1, 1, 0. And x3 equal to 1, 1, 1. This is model matrix. So if that P not equal to 0, then P inverse exists. Then we write the diagonalization matrix D equal to P inverse AP. So if you find the modulus of P, what is the modulus of P? Modulus of P చెప్పండి
minus 1.
So what is modulus of P?
Minus 1.
Minus 1, which is not equal to 0. Therefore, P inverse exists. So find the P inverse value using calci. So what is P inverse?
Minus 1.
Minus 1,
1.
1,
0.
0,
4.
4,
Minus 3.
minus 3,
Minus 1.
minus 1,
Minus 2.
minus 2,
2.
2,
1.
1. So this is P inverse of a matrix. So now write down the diagonalization of the given matrix. Now diagonalization of A, that is D equal to P inverse AP. So D equal to P inverse matrix is minus 1, 1, 0, 4, minus 3, minus 1, minus 2, 2, 1 into A matrix 1, 1, 1, 0, 2, 1, minus 4, 4, 3, and P matrix P equal to 1, 1, 1, 2, 1, 1, minus 2, 0, 1. So by multiplying these three matrices, we get the diagonalization matrix. That is, so what are the eigenvalues we have? Those are the diagonal elements in the diagonal matrix, and the remaining all are 0. Suppose if you multiplying these three, you get the same matrix. Otherwise, that is wrong. So if you multiplying these three matrices, you get this one. So directly we write 1, 2, 3 are the eigenvalues. Those are the diagonal elements, and the remaining all are 0. So if we ask to find the powers of A, suppose powers of A, that is A power 4 or A power 8, anything, we write A power 4 equal to P inverse into D power 4 into P. Directly don't know A power 4. By using this method, you find the powers of A. Either A power 4 equal to P inverse D power 4 into P, or A power 8 equal to P inverse D power 8 into P. Okay, this is the diagonalization of a matrix and powers of A to find the powers of A. Understood all of you?
Yes, sir.
Okay.